All right, now we're going to look at trying to get the volume of these shapes made with parallelograms, which is a parallelepiped. The formula to do so is the volume equals the vector u multiplied by the cross product of v and w. And we take the absolute value of that, because a volume cannot be a negative number. All right, so down, and there's a picture down here as far as what one would look like. Let's see. I'm just going to do, I'm not going to sketch it, but I'll do parts A and B if I can here. All right, so we're given the points A, B, and C. So all we need is 3 as far as that goes. We need to find a real number alpha, which is non-negative, at greater than 0, strictly greater than 0, such that the volume of the parallelepiped is 3 units cubed. So our volume is 3. All right, so that's given. Now, essentially, we're going to just use our formula and solve for that. So what we have, and we'll get back to this other formula in a minute, V, which in this case is equal to 3, is equal to the absolute value of U So we're using the formula from above there. All right, so this is a triple scalar product, so we can use our matrix determinant for it. So we have 3 equals, I'm just going to write absolute value of this whole thing. I don't want to draw lines around lines. Our A, which will be our U here, is 2, 1, 0. It's our first one. And then we have our V is 1, 2, 0. And finally our W is 0, 1, and then alpha, as I recall. Just verify that. 2, 1, 0, 1, 2, 0, 0, 1, alpha. So I'm taking the determinant of all that. So our first value in the upper left is 2. And I've got 2, 0, 1, and alpha. Minus 1. I've got 1, 0, 0, and alpha. And then plus 0, and I'm not going to put the determinant in there because it doesn't matter because we're multiplying by 0. All right, so we have 3 is equal to the absolute value of 2 times, well, it's 2 times alpha there, so 2 alpha. And then it's subtract alpha and then 0. So this, so 3 is equal to 3 alpha. We've got 4 alpha there, minus an alpha is 3 alpha, which means that alpha has to equal 1. Because again, alpha is greater than 0. So that's the alpha for that, and that's part A. Let's go see what we need to do for part B. Well, they tell us for alpha equals 1, so I guess maybe they knew what the answer was going to be. Find the height h from the vertex C of the parallelepiped. I'm not going to sketch it, but we need to do that. So essentially we need to find the magnitude of the projection. So we're looking for the length of this guy here. And we can do that using this formula here. Now we talked about projection in the previous section. We didn't actually cover this this formula. It was on one of the videos, but we didn't actually do an example with it. But we have u dot v, and in this case, our v is going to be v cross x. So we already have the numerator. So let's write that. So all right, so we're looking for, this is part B, the magnitude of the projection, and that's going to be v cross w as a subscript, u. That's u dot v cross w, all over the magnitude of v cross w. Now note, this is just the volume, which equals 3. So our numerator is 3, this part, the top part. So really all we have to do is calculate the denominator. So I'm going to calculate v cross w first. So we're going to use the determinant method. These two, I think, so 1, 2, 0, and 0, 1, and now we know 1. So 1, 2, 0, and 0, 1, 1. We're solving for this. 2, 1, 1, 0. This one's, excuse me, minus not equal. 0, 0, 1. This one's J. 0. All right, so our determinants of each of these, so this looks like 2i minus j plus k. 1 times 0, or 1 plus 0, 1 minus 0. All right, so that's what we have. And the magnitude of that is going to be the square root of 2 squared plus negative 1 squared for the j, and then plus 1 squared. So that's 4, 5, 6, or root 6. So if the top is 3 and the bottom is root 6, that means our projection will be equal to 3 over root 6, or you can rationalize that as root 6 over 2. That'll work.